Hello and welcome to yet another video of Cornerstones of Math. In this video, I am going to find the limit of sin x minus tangent x divided by x cubed when x approaches 0. And let us dive right into the question right here. Do we really need a cube in the denominator? I mean, yeah, these types of limit problems are quite popular and there can be many problems in this form, but surely the power doesn't need to be as high as 3, does it? Well, the truth is, the power in the denominator needs to be 3 if we want the interesting result. You see, as for this limit with the denominator x to the power of p, if p is less than 3, then the numerator approaches 0 much faster compared to the denominator, hence the limit is just 0. On the other hand, if p is greater than 3, then now the denominator approaches 0 much faster than the numerator, hence the entire thing diverges. However, if the power p is exactly 3, then the numerator and the denominator approach 0 at approximately the same speed, making the result interesting. Also, let's talk about the methods. Some of you may already know some advanced tools such as Taylor series or Maclaurin series, but I rarely use them in my videos because declaring that I know some advanced math concepts and just using them is boring and not that educational, especially when there are less advanced, more commonly known methods we can use. So first, I will use L'Hopital's rule, which is surprisingly not that fast compared to the other method, which does not use the L'Hopital's rule. So first, let's use L'Hopital's rule and see how fast this method is. This limit is 0 over 0 type indeterminate form, so we apply L'Hopital's rule. Then the numerator becomes the derivative of sine x is cosine x, and the derivative of tangent x is secant squared, and the denominator becomes 3x squared. Notice that this limit is still in 0 over 0 form, so we apply L'Hopital's rule again. So the derivative of cosine x is minus sine x, and as for the derivative of secant squared, we apply the chain rule. First, the power rule gives 2 secant x, then we have to multiply the derivative of secant x, which is secant x tangent x, and the denominator becomes 6x. So we have minus sine x minus 2 secant squared x tangent x divided by 6x. However, the limit is still in 0 over 0 form, so we apply L'Hopital's rule again. So in the numerator, we have minus cosine x, and for the derivative of secant squared x tangent x, we use the product rule. So first, the derivative of secant squared x, which is 2 secant x times the derivative of secant x tangent x, then this remaining tangent x. Next, secant squared x times the derivative of tangent x, which is secant squared x, and the denominator becomes 6. So we have limit of minus cosine x minus 4 secant squared x tangent squared x minus 2 secant to the 4th power x divided by 6, and now we can finally obtain the value of the limit as it is not in 0 over 0 form anymore. So we have minus 1, then the next term is 0, and the next term is 2, so this divided by 6, which gives negative 1/2. Alright, this time let's solve the problem without using L'Hopital's rule. But instead of L'Hopital's rule, now we have to use this very important limit. The limit of sin x over x where x approaches 0 is equal to 1. So our goal is to extract this sin x over x term whenever we can. Let us change tangent x into sin x over cosine x. Here you will notice that we can already extract sin x over x term to the front. Then the remaining term is 1 minus 1 over cosine x divided by x squared. Here we can write the second part as cosine x minus 1 divided by x squared cosine x. Here this cosine x in the denominator is not a problem because it approaches 1. But we have 0 over 0 form here because of the remaining cosine x minus 1 over x squared part. In order to deal with that, we multiply cosine x plus 1 on both numerator and denominator. Then on the numerator, we have cosine x squared minus 1, which equals minus sine x squared. Therefore, we can take out sine squared x over x squared, and what remains now is negative 1 divided by cosine x times cosine x plus 1. So we have this part goes to 1 and this part goes to 1 as well. And as for this part, we have negative 1 divided by 1 times 1 plus 1. So we have negative 1/2. And considering that we had to use L'Hopital's rule 3 times in the first method, this non-L'Hopital method is actually not that complicated compared to the previous method. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.